Nvidia just released groundbreaking AI engines that revolutionize game development. For the first time, small teams can create assets, animations, and graphics that rival AAA studios. Here are these revolutionary tools and how they work, and why I'm glad that AAA studios now have to fight for their survival. Nvidia's first AI engine doesn't just make individual assets, it makes entire scenes. With this AI, the process starts by prompting the AI for a scene. Then it suggests the individual objects, and if the designer is satisfied, it builds the 3D geometry. As if that wasn't amazing enough, the AI then goes on to build environment maps. These orbs represent the environment. They fill the background and set the lighting of the scene, so you don't have to do it manually. It already looks like an amazing starting point, but the AI also helps you to further customize it until it exactly fits your style. Like, you can decide on a nice overarching theme. How about a gold rush theme? This alone hits the reset button on access to game development. But we are just getting started. Nvidia calls this Edify 3D, or high quality synthesis. So what does this AI exactly do? It can generate scenes with just a text prompt. It can do a variety of objects and styles up to 4K texture resolution. These outputs are 3D meshes, so you can always further customize them if you like. It also generates geometry based on an image, so you have a lot more control on the style and consistency. This would take a designer hours and hours, but the AI does it in just about 2 minutes on a fairly low-end hardware. This engine is very small by today's standards. It has only 2.7 billion parameters. If you have one of the newer phones, you might be running models of similar size on it locally without knowing about it. The next AI engines are even more powerful. But before visiting them, how much does this actually change the gaming industry? Let me answer that by looking at the top 3 most popular games on Steam right now: Counter-Strike, PUBG, and Dota 2. Why do you think all of these games were mods of other games? Mods or custom games allow developers to give the community the tools to modify the original game, creating new gameplay experiences with different rules. Dota was a custom game inside Warcraft 3, and then Valve made Dota 2 based on that, which started a whole new genre, with League of Legends being the most popular one among them. Counter-Strike was a custom game inside Half-Life, that then turned into a standalone game. And for PUBG, Brandon Green modded Arma 2 and Arma 3 to build DayZ Battle Royale, and then moved on to build PUBG using the Unreal Engine. Kind of like League of Legends isn't exactly a mod of Warcraft 3, but it was based on the same tested idea. That just goes to show the power of giving people access to develop their ideas. These custom games didn't have much freedom either, but the already built game environment and assets gave some random people the ability to make some of the most popular games and genres ever. Mods aren't just assets and environments, they contain game mechanics and animations. So that's when Nvidia's second AI engine comes in. Nvidia has introduced a bunch of different tools for different scenarios to easily build game mechanics and animations. Before this, animating game characters as well as big companies was basically impossible. Animating inside the simulator is really hard and time-consuming, and motion capture is really expensive. Imagine you are building a sports game like FIFA Soccer. Traditionally, you'd need to hire athletes to perform the motions, use motion capture equipment with specialized tools like colored markers and gyroscopes, and employ advanced software and expertise to translate those movements into your game. Now here's the twist. Nvidia has developed a demo game that mimics athletes' movements without any motion capture. This AI analyzes raw footage and recreates the motions. Initially, the imitated movements appear sluggish, but by applying a physics-based simulation technique, the results become incredibly lifelike. So much so that they surpass traditional motion capture in quality. You'll soon see why this is revolutionary. With this technique, you can even instruct the AI where you want the ball to go. Based on the ball's position and the player's stance, the AI calculates the optimal movement and generates the appropriate animation. Remarkably, the resulting animation looks stunning even from a side view. Here's the problem though. In a real game with numerous characters, you don't want them all using the same animation. This is one of the reasons smaller studios struggle to create ambitious games. Larger studios like EA can afford to hire multiple athletes and also invest in post-production customization to create diverse styles. However, this AI can dynamically mimic different player styles on the fly, whether it's playing with the left hand, right hand, or even using two hands. The AI adapts seamlessly. When you pit two of these AIs against each other with distinct styles, The result looks so natural that it could easily trick you into believing it's a real match. And remember, this is just a demo. Imagine how much more realistic it could become with additional polish and fine-tuning in a fully developed game. It might even be indistinguishable from reality. What if you need animations and game mechanics for something you don't have any reference footage for? Like medieval-style sword fighting. You could hire someone to perform the motions and capture them using the earlier technique, which doesn't require much equipment. Or you could use a groundbreaking technique where the AI learns on its own to create natural animations. Now imagine these characters have been training for 10 years. Not in real time, of course, but in a simulated environment. We'll talk about what that translates to in real-world time a bit later. The process begins by feeding the AI a rough example of the motion. It doesn't need to be precise, just enough to represent the movement you are aiming for. After just a week of training, your warriors might look hilariously uncoordinated. Don't worry though, after 4 months, they can stand on their feet. They begin to exhibit true fighting moves, even sneaking away in style. What's more impressive is that these warriors develop their own unique styles, all of which look natural and convincing. But what happens after 10 years of simulated training? Let's take a look. MashaAllah, the result is fantastic. Their fighting styles are not only unique, but also incredibly refined and lifelike, an astonishing leap in AI-driven animation. The unique feature of this AI is that it fills the gaps by itself. We started with a bunch of main animations like running, sitting, and fighting, but now the AI can naturally combine them and also fill in the transitions. Look at this demo where the soldier needs to place his sword where the red ball is, and it synthesizes all the necessary animations to get there by itself. So how much real-world time did these 10 years of simulated training take? Surprisingly, all these soldiers were trained in just 10 days. Granted, this was done on a highly capable machine, but even if you don't have access to such hardware, paying for 10 days of compute is likely feasible if you are working on an ambitious game. This technique front-loads most of the computational effort during the training phase. Once the training is complete and the desired animations are captured, running those animations in the game requires significantly less computational power. This means you don't need a high-end machine to play the game at the end. But Nvidia didn't stop there. The last technique takes things a step further. It doesn't even require training if you are not aiming for hyper-realistic animations and just need something functional. Nvidia has developed an AI that can generate animations on the fly based on simple instructions. For example, you can draw a line and the character follows it. Set a destination and the character goes there in various styles. Connect the joystick and the character responds to your controls. You can even provide pre-rendered poses and have the AI feel the movements between them. The best part, it all happens faster than real time. There is no pre-training involved. It simply performs as instructed. While this method is more limited and less fluid compared to pre-trained systems, it offers an unprecedented level of creative freedom. It's not even comparable to the constraints of modding someone else's game. We've got the assets and animations, but can our game look as good as AAA games? First off, looks aren't the biggest factor. What matters more is having a game that's fun to play and responsive. That's all you really need to create a massively popular game. With the hilarious flops like Concord from Sony Pictures, Dragon Age Veilguard from Electronic Arts, and Skull and Bones from Ubisoft, this model is already falling apart. Some AAA studios don't make games anymore. They just milk IPs, use their money to make a good-looking bad game, and false advertise it inclusion with media outlets to hustle their customers. But still, AAA studios have had an unfair advantage that has protected them for a long time. And that unfair advantage was access. If you've ever tried to make these stupid static donuts in 5 hours, you know building game assets is an excruciating process. Small to medium-sized teams of game developers have had to either buy some generic asset package that didn't necessarily fit their game style, or limit their ambitions, work long hours for years, and build their own assets. However, if you do want to make your game look better without a big budget, Nvidia's third AI engine is incredibly powerful. Imagine bringing this scene into your game. Could it actually look this realistic? Would it blow your mind if I told you this isn't real footage? This is what the scene looks like inside the game. How's that possible? It's the result of two revolutionary techniques that weren't supposed to be compatible, but Nvidia somehow made them work together. You've probably heard of ray tracing. It's a rendering technique that simulates how lights interact with objects in the real world to produce more realistic lighting and shadows in digital environments. This technique uses millions of light rays to create realistic reflections, refractions, sophisticated material models, and lifelike human skin. While it delivers stunning visuals, it's very compute intensive and slow. Though optimized versions are being used in games, just not to the level of true ray trace realism. On the other hand, there is Gaussian splatting, which builds objects using particles instead of traditional 3D geometry. It's lightning fast, often faster than real time, but it struggles with lighting and eats up a lot of memory, which can be costly on today's graphics cards. Nvidia researchers have managed to fuse those two techniques into one single unified algorithm, and the results speak for themselves. These scenes are unlike anything we've ever seen in a video game, pushing visual fidelity to new heights. But how fast are they? These scenes can run as high as 75 frames per second, which is impressive. However, for really complex scenes, the frame rate can drop to 10 FPS. Though that's without pre-rendering and with the entire world being rendered in real time. For a real-world game, pre-rendering happens a lot to make games playable. So we've already got a game with stunning visuals and amazing animations. But the last piece of the puzzle is bringing it all together. Everything we've discussed so far is powerful and useful, but the true strength of these tools lies in making them accessible. There aren't that many crazy AI experts working on games, so the real magic happens when all these advancements are packaged into an easy-to-use toolset, enabling developers to unlock their full potential without needing to be experts themselves. I think a game is a great experience when the creator has made it with love and passion. That's the missing ingredient in modern entertainment. Only a passionate creator can craft a jaw-dropping experience that leaves you staring at the monitor for minutes after the game ends. By democratizing tools, we can unlock next-level experiences that small teams can achieve. Experiences that AAA companies won't be able to compete with. Even without the passion, just looking at it logically, a lot of small teams can explore the realm of ideas much faster than just a handful of large corporations. That's why game engines like Unreal Engine or Unity are so crucial. They are the bridge that connects all these breakthroughs to the developer, and Nvidia is partnering with all major game engines to bring these technologies to developers. Now that everyone has access to the same tools and there is no monopoly on realistically building ambitious games, I want to see how these soulless corporations can compete with passionate game developers. Nvidia is also offering custom SDKs for those who want to develop outside the main engines. Of course, it takes more effort, but it could be a smart long-term move to set yourself apart from the competition. These new breakthroughs in AI are set to be integrated into all major game engines soon. And when that happens, we'll see a new wave of games being developed by smaller teams that can rival and surpass AAA experiences. With the power of these AI tools now available to everyone, it's only a matter of time before indie game developers create experiences that push the boundaries of what we thought was possible in gaming. The playing field is leveling, and the future of game development is looking incredibly exciting. My name is Purya, and I bring you the hottest tech videos. If you enjoyed the video, you know what to do. Thanks for watching, and have a great day.